Okay, hi, I'm Ryan Salyers, and I'm gonna go over my Lab 9 project. So basically, it is a cooling fan or a thermistor that basically uh, is used to act as almost an air conditioning. The thermistor, you can kind of see it under there. It's placed with inside of the fan right now, and it has a 10K ohm resistor to match its resistance in the voltage divider. Right, so that's being read through the 0 port on the Arduino, right? And then the motor is being controlled by a transistor with the base current or voltage coming from the Arduino. I'm gonna go through the code here in a little bit. And then it's then channeled, right? So when the base current is applied, the external voltage is then gonna be applied and used on the motor. Right, so going forward, right, so in order to control the temperature, I did notice I had a problem that the fan was really not able to provide enough heat transfer to the device. So what I've decided to use is a means of having it control an already cold air, right? So what I'm doing is I'm gonna use this ice pack, right, to provide the cold air to create better heat transfer from the thermistor, right? And that's going to be controlled by the actual speed of the fan, right? So as the fan is going to be taking in the colder air, it's going to decrease in temperature. You can see it here on the chart here. It's going to slowly go down, and then once it hits its temperature on the Arduino code, it's going to do some things in processing, which I'll show here in a little bit, but just a demonstration that this is how I'm getting the temperature to go down. Right, so from here inside of the processing or inside of the Arduino code, I have a few things, right? So I did use a reference here to help with the conversions and stuff because I was a little bit confused. But basically how it works is, so I have input data from the thermistor itself right here. That's gonna be, right, your analog read. That's then gonna convert it into temperatures in degrees Fahrenheit. It's going to print it to the serial monitor so it can be attached to the processing. And then this is really what controls the motor down here. Right, so if the temperature is set by the user, right, I have it 50, that can be changed to any temperature that you want within reasonable means of what we can actually get in terms of temperature change. Right, so if your temperature set is less than the temperature it currently is, meaning that it's too hot than desired, you're going to turn the fan on and it's going to bring in that cold air into the system, right? Once it becomes either less than that, right, they also run and it'll turn that fan off, right? And then I'm going to be taking data every 500 milliseconds. Right, that's the Arduino. Okay, so now on to processing, right? So up here at the top, I basically just do some pretty general background work, set up some things, right, in the my port, trying to get the information from the serial monitor here, right? And then we're going to be assigning a string here, an array with multiple different tokens, right? Those are just going to be those things printed from the Arduino. So like the set temperature declined by the user, and then the actual temperature of the area, right? I'm going to assign those variables here. And then I also created a difference. I wanted to do this because I wanted a little bit of a margin of error. Like it's going to be kind of tricky to have it regulated at this level to an exact, few decimal points. So I said if it's between 0.25 degrees, it's okay, and we can give it the green light to stop the motor, or to at least read or tell the user that we're good to go. Right. So I have it in red in the back here. I'll bring it up here now as kind of a better demonstration. You can kind of see side by side. But this is the basic thing, right? So this is when it's in a cooling notion, right? So as it cools, right, you can show here the applied. Right, so now we'll see the temperature start to slowly go down until it hits our desired temperature, and then it goes green, right? So that's kind of the idea of this, and then it's gonna kind of, as I remove the cooling source, it kind of goes away. But yeah, it's pretty basic stuff, but it looks pretty good. That concludes my lab.